Greetings, our team here presents you our AI-driven flood detection and response system for authorities and communities with integrated smart drain sensors for accessible and low-cost dual platform for flood disaster management. So what we have found is that currently in just 2021, there's over 71,000 Malaysians were affected by flash floods, and there's so many cases of flash flood in Malaysia and leads to many deaths and also finance losses. So what causes all this? We found that for authorities side, there are gaps in good monitoring implementation by the government for knowing when the flood is coming, and also there's communication and coordination gaps, and of course, unnoticed poor drainage infrastructure and where to improve them, as most floods are caused by poor drainage systems. And for residents-wise, they are living in flood-prone areas, they have a lack of timely emergency alerts, no real-time evacuation guidance, and also difficulty in requesting help and locating their loved ones. Therefore, our targeted users will be the local disaster agencies, Malaysian families in flood zones. So we would like to present you our solution and our hardware implementation. So allow us to show you our demonstration of our product. So this is a web platform. So for example, let's log in from the authority side. So let's provide an email. And when sign in, you'll be greeted with the dashboard. So for our platform, we're actually integrating the weather API. Basically based on weather and also other risks. Basically our system will categorize from across the Malaysia. We'll categorize which states will be having floods that might occur using our AI analysis, and also the risk distribution categorizing by high risk, medium risk, and low risk, and a national risk score. So from the data view side, for here in each of these areas, there's a high risk value we can view in more details. So for example, in Kota Baru, there's a lot of flood that's happening. So here, our system will categorize based on the data gathered from data government.my. We'll basically categorize all the household by which household having the most risk household and vulnerable residents and the resource readiness and the flood risk level using our AI analysis. So we want to categorize like which household we need to prioritize the rescue. For example, these houses we categorize like vulnerability groups like elderly and disabled, and we prioritize the rescue first. And also we'll be having a resource prediction like from this area in Kota Baru, if the flood will happen, so we will need to predict how much resources will be needed, and also the resource distribution and the transportation and personal requirements. So we also have a material coordination to know that where we can source the closest supplies to give us all these goods to basically supply to these flood areas if it happens having a flood, and we can track all the orders and also the distribution center and distributing the goods. And next, we want to coordinate. So we have a coordinate functionality. So in this coordinate functionality, we basically, for example, this is the first happening in Taman Sri Muda. So we can actually use the AI agent. So for example, when we contact the nearest bomba for Taman Sri Muda, basically our system will automate the process of contacting the bomba straight away, and also we will know how many volunteers are available, and also the authorities will be able to be deployed. And next, for simulation. So in simulation, we can actually using our AI algorithm, we can actually predict, for example, in maybe in Terengganu, and for example in this major city, and then we specify an area like Terengganu, and we can specify what's the rainfall intensity and our rainfall duration, and we can choose the terrain type, and let's run the simulation. So we got the result in Terengganu that there's a high risk level that the flood will be happening, and we basically provide estimated affected population and estimated economic impact to allow the organizers or authorities to plan better. And next, let's log out. For the residents who are living in the flood disaster prone areas, we also provided them a platform for them to view. So in here, in their dashboard, they can always get the real-time alerts of whether a flood is happening, and now currently there's a flood that will be incoming, and the water level that's showing the water level and evacuation status and their nearest shelter. And here we have a family member tracking to check everyone is here. And also we implemented SOS geolocation data tracking. So as well, they press this and this is their current location. So when they send the SOS signal, the platform will send their geolocation data to the nearby authorities to come to their rescue. And now the SOS signal has been sent successfully. And evacuation wise, we also provided evacuation. So for evacuation, we also provided evacuation route, AI generated evacuation route that routes them to the nearest recommended shelter in the closest and basically the safest path. And that's all for our platform demonstration. This is our prototype of smart drainage sensor system. So this prototype represents a simplified model of a city's drainage system. It includes an open drain, manholes, and underground drain. So we have integrated various sensors into the different type of drains to form a large IoT-based smart drain monitoring system. So our sensor includes flow meter sensor to measure the flow rate within the drains, flow sensor to trigger an alert when water reaches a specific height, and ultrasonic depth sensor to measure the water depth in the drain. And each type of drain utilizes a specific combination of sensors. So all these sensors installed with powered by solar panel, and the collected data is sent to Firebase, where it's stored in the central database. And the mathematical AI model is then applied to analyze the data and predict the time and likelihood of flooding based on the flood drains and real-time forecasted weather conditions. So to implement our system, we're actually for our front end, we'll be using Next.js, Kiew CSS, and other packages. And for our AI advisory and agent, we'll be using LangChain and Gemini. And for prediction AI model, we'll be using Hugging Face open source model and PyTorch. And our database is Firebase, and backend is Fast API. And the database is connecting with our hardware, our flood gap detachable smart drainage system sensors. And for business model, will be our revenue stream will be from government and municipal grants, particularly from the local disaster agencies, and providing data insights for property developers, sponsor alerts and ads for emergency services in our platform. And for long term, we'll be involving subscription-based services and scaling up to other disaster types. And so what our solution stands out, it provides a dual platform coordination, AI-driven risk profiling and resource prediction, integrated evacuation intelligence, smart hardware integration, end-to-end volunteer and authority coordination, and lastly, family safetiness. And for impact, we'll be providing SDG, we'll be allowing. So our impact will be SDG 11. So our impact aligns perfectly with SDGs. So our SDG achieved will be SDG 11, improving urban resilience. SDG 10, reducing inequalities and prioritizing health for vulnerable groups. And SDG 13, supporting proactive disaster response. And SDG 3, reducing injury and trauma and loss during flood emergencies. And thank you. So for future development, for short term, we'll be aiming to build an MVP, and for mid term, we'll be expanding to other high-risk flood states. And for long term region, we'll be establishing a national disaster tech network powered by real-time IoT data with our platform. And thank you for listening to our presentation.